Good afternoon, everybody. My name is Emory Fry. I'm the now Chief Medical Informatics Officer at a little company called Cognitive Medical Systems. I'm going to take a slightly different approach to this RDF stuff and talk about it in terms of sort of practical clinical terms. And given that the heading of this section is where are we now, I'll talk about some projects that are going on in DoD, the Interagency Program Office, which is a DoD VA organization, and some work that we're doing with VA. From a clinical perspective, I think this use case here that I'm calling sort of a lost in translation use case is pretty clearly evident in any domain, where subject matter experts will spend hours and hours, days and days, describing their functional objectives, their requirements, their processes, the need for orchestration, clarifying their semantics, and literally beat their heads into a pulp, trying to get the other participants in this complex process that they're trying to model, get the semantics of that straight. And then the engineers will go off and spend an order of magnitude greater time building, prototyping, translating, and coming back weeks, months later and have their SMEs, their subject matter experts, look at them as like they were just delivered out of an alien. Where the result of what they understood is really not aligned with what the subject matter expert was trying to say. So one of those areas is clinical decision support, and this is sort of my passion. How do we reason over healthcare data in ways that ultimately, according to this definition by Jerry Osheroff, provide knowledge and person-specific or population-specific information intelligently filtered and presented at the right time. So when you look at that definition, there are clearly four dimensions that definition involves. Data structures, semantics of that data, processes in which a reasoning system like a clinical decision support engine needs to be able to understand at what time in a process, either a workflow orchestration or a rule execution, what state that clinical process is in, and then apply the right reasoning technology, the right inference capability to the problem at hand. And what I'm briefly here going to try to articulate is how semantic web technologies can help that. So the first of those requirements, data structure, CDS, clinical decision support, requires obviously an appropriate collection of comprehensive and detailed information that is structurally consistent. You can't reason over data that is structurally different. So from a very pragmatic perspective, we need to be able to harmonize our data structures. And obviously RDF is, and I won't belabor this because other speakers have covered the aggregation and structural normalization capabilities of RDF earlier, but fundamentally concepts like same as, equivalent class, equivalent property in an ontology allow us to structurally aggregate and normalize larger corpuses of medical information so that we can reason over more complete data. Simplistically said, if you have more data, more complete data, your choices and decisions may be better. Similarly, CDS requires information that is semantically consistent. Stan's going to talk about this in more detail later, but fundamentally, current terminologies, the ones that we use to label things in healthcare, struggle with context. They struggle with part and whole relationships. Is something a constituent part or not? We, as domain experts, struggle sometimes to understand that when my nursing model says something and I say something as a physician, that we're actually meaning the same thing. So semantic equivalence is a real problem. And then the whole issue of the explosion in medical terminology and pre- and post-coordinated approaches to semantic management is causing an explosion in quantity and complexity that needs better approaches for management. And OWL obviously has OWL semantic reasoning sorts of ontology approaches to this, has tremendous advantages in terms of being able to apply unified descriptive logic to semantics, exposing explicitly what those definitions are, and have a more academic and public conversation about meanings of things that is sometimes lost when the engineers start talking about UML laws. This gets to this thing that I don't exactly know how to describe this from an engineering perspective, but from a medical perspective, and if I know Stan's a physician, so that if there are any other physicians in the room or people who are involved in day-to-day healthcare, this sort of multidisciplinary meeting where we try to coordinate our worldviews, where nursing, social services, legal, risk management, physicians, respiratory therapists have team meetings, multidisciplinary meetings, and try to figure out what the hell we're going to do in order to take better care of the patient. That is fundamentally a multidisciplinary orchestration event that requires that our semantics be understood. They may not be aligned, but there's a tremendous amount of information that is lost in translation when we don't precisely describe what we mean. In OWL and a focus on conceptual modeling, which is probably the more appropriate place for a domain expert to be modeling as opposed to the data structures in a UML model. A domain expert modeling or attempting to model their worldview in OWL is making explicit some of the things that then can be either challenged or integrated or harmonized with other domain experts sitting in the room. And I think there's a process here of domain model alignment that ultimately becomes an educational process for the entire team. And this isn't an engineering issue. This is simply a knowledge management and knowledge accelerator. This is a force multiplier, as they say in the military, in which when understanding becomes clearer, you can build upon block by block and ultimately deliver a process care, a care process that is fundamentally more sophisticated, clearer, and all parts of your team are working together. And it's really hard to describe that in engineering terms, but I think if you translate to any sort of multidisciplinary coordination experience that you may have in your own domains, this is not unique to medicine. It's unique to any organization that is attempting to improve a process, because there are different pieces and perspectives of that process. And domain modeling and domain ontology alignment is a powerful tool. One of the most important or satisfying things that I've experienced using RDF and modeling tools like Protégé is the light bulbs that go off when I finally understand what my nurse is saying. And I finally understand what risk management is so upset about. Okay. Now, my particular focus or my particular interest is in sort of cognitive support, cognitive medical systems, kind of self-explanatory. And let me sort of describe this by saying the reasoning systems ultimately, ideally, would deliver the right type of reasoning to the situation at hand. And not everything is a production rule. A production rule being, a specific type of logic, A plus B equals C type rules. Most of our rules engines are production rule systems. And they have certain requirements structurally or semantically. We happen to use Drools in our work, which is Java class-based reasoner. But fundamentally, the rules are not the only type of reasoning that applies to clinical care. And ideally, a clinical decision support system would be a hybrid system that would deliver at the appropriate time in the care process the right type of reasoning applied to the data that is presented in the right sort of way. So fuzzy logic, defeasible logic, that sort of nuanced reasoning capability can have potentially a profound impact on whether or not the right choice is made for a particular patient. And this gets into the, Claude, I told you I took this slide out, but I actually didn't. This gets into the subtle but profound distinction between open and closed world reasoning. Most of our rules systems, the Oracle rule engine, the Java rule engine, those are closed world assumptions. They have the closed world assumption where if something is not known to be true, it is by definition false. That's not the way medicine works. And the way medicine works, particularly in this coming world, where we are going to have federated data sources whose provenance, I'm incredibly interested in provenance, whose provenance of that data is unknown. That raises all sorts of different perspectives in terms of how we reason over that data. Some of it is the data structure itself, but some of it is also what type of reasoning and what type of assumptions you apply to that data as you reason over it to make better clinical choices. So what am I trying to say? In a very long-winded way, I'm basically saying use the right tool for the right job. And in this situation, domain experts, subject matter experts such as myself, who went to med school, take care of patients, and are not engineers, I personally have found that when I sit down in front of Protege and start to try to explain what I mean by something, it's a whole lot easier to deal with a conceptual, a tool that allows me to describe concepts as opposed to a UML model and using the various UML diagrams in there to describe sequence diagrams and all those different artifacts that quite honestly seem divorced from the real message or the real intent that I'm being brought to the table to provide. All right, so where are we really in terms of semantic web in DoD? Well, what's kind of interesting is in 2008 and then in 2010, DoD, VA, and most of the federal agencies were involved in NN and then in VLER, Virtual Lifetime Electronic Record demonstrations, and I happen to have been involved in those programs. And the emphasis and the focus of the federal government, the healthcare entities within the federal government, were very, very focused on interoperability and less on creating a new EHR. And there was a lot of discussion back then about RDF and how better to model domain objects as they're being transferred from one organization to another. And then came the PCAS report. And even at this conference in 2010, the DCMO, a DoD entity, their CTO, ultimately gave a talk, a keynote speak, that resulted in a Navy instruction that basically, or DoD instruction, that basically mandated that BPM and for the process side and RDF-AL for the semantics and modeling side would be the preferred technologies. So there was this concept in late 2010, early 2011 that we were going to see a renaissance of RDF and semantic web adoption. Well, what really happened was MHS, VA, and to a certain extent the Indian Health Service got dominated, the conversation got dominated by IHR, the Integrated Electronic Health Record. And what essentially happened was an extremely slow adoption and a procurement process, a design process that continued to be driven by policy, political, and agency sort of ecosystem momentum that kept driving a traditional relational database and service-oriented architecture approach to designing new systems. And so basically, we've had no significant adoption at the corporate level in the federal healthcare space, despite all of this momentum that started back in 2008. Now, that's not to say that there haven't been any projects. So just to kind of wrap up this little 10, 15 minutes section here, there have been some projects, ones that Connor and I have done and various other people have done, looking at the adoption or the use of RDF and semantic web in clinical applications. This is my baby, the knowledge management repository, where the basic idea was how do I write a rule that can be executed across, shared and executed in different environments. Well, it's not rocket science. You need those four pillars. You need to understand the context of the rule, the structure of the rule, the semantics of the rule. And we did some work with Connor in which we modeled, because at the time, this is 2007 through 2010, at the time there really wasn't an HL7 object model. So we modeled an EMR with the EMR domains in OWL, or in an ontology, and then managed to assemble a series of open source tools to auto-generate the XSDs and the Java classes directly from this knowledge model and use those artifacts in the runtime system. One of those runtime systems I'll show you in a second was an authoring environment that allowed me to import my classes into the Drools authoring environment and then manage both workflow and rule modeling in a graphical tool that was designed for providers. And we used a triple store mapping triples to ultimately take RDF graphs that Connor's stuff built on Indian Health Service, Alta, and Vista, and did a demonstration at HIMSS where data from 3 different federal systems was aggregated and a single rule was executed on an aggregate of all that data. This is just a quick example or a quick slide of what that sort of graphical workbench prototype was. And the data models were originally built in OWL and then exported as XSD Java classes and loaded into Drools. There's another project actually going on right now at the Interagency Program Office that's using RDF and then semantic descriptions of clinical system interfaces within the entire MHS, Military Health Service, for which there are thousands of interfaces. I mean, there are hundreds of systems, thousands of interfaces, and they've cataloged those interfaces as RDF, and they built this now open source tool called CMOS, that allows you to graphically represent, drill down, and zoom out of this graph, this interconnected graph of interfaces, and allows you to sort of explore your world in the same way that the Connor's Rambler allows you to explore a graph of CHCS or Vista data. They're similarly looking at how RDF and graph representations of connections, relationships between interfaces within the MHS, can be visualized more effectively in a simple tool. The data, obviously, that this CMOS tool is being used is not open source, but the framework is now on GitHub as of a couple of weeks ago.
I think you actually put it up, you put everything up the weekend.
Yeah, it was like a week ago. Yeah. We're currently doing a project in which we took RX Norm, SNOMED, LOINC, NDFRT, and a couple of other medical vocabularies and actually built true SCOS ontologies from those vocabularies. If you go to the National Biomedical Informatics or National Center of Biomedical Ontologies and look at their CTS2 tool, that tool really allows you to query and use CTS2 Sparkle to query an individual vocabulary. But the vocabularies themselves, because of the way the site is structured, doesn't really allow you to do a lot of crosswalking. So Connor, in this project of ours, we sort of cleaned up, at least for certain limited areas of these vocabularies, cleaned them up, put them into a SCOS vocabulary, and then built a CTS2 interface on Jenna, and are exposing the crosswalking between these various SCOS vocabularies in Jenna. And we're doing this as part of an IHR research project to try to get particularly the DoD and the VA to consider alternative terminology services for their mid-tier. Right now they use a product that I keep referring to Stan because he created most of this, that the 3M subsequently commercialized, called the HDD. And now with RDF and particularly with CTS2, which has curation APIs, there may be better ways to do this. I need to show that. Okay. And the last thing is we have a project that Connor referred to here briefly, which is natural language processing on SPL data that we then subsequently took in, massaged into RDF graphs and exposed clinically in a clinical bedside application that basically